Okay, so let's continue on talking about equations of lines. We already talked about really what the f of x equals mx plus b is all about. If you had an f of x equals mx plus b, that was what was called a linear function. It would really represent, if you were to graph it, it would be the same thing if it were a y equals. So that kind of works both ways. Same idea. So let's talk about being able to find the equation of a line if you're not given the equation of a line. So there's a couple of formulas that I think would be worthwhile for us to know. Okay, and a couple of those formulas are written right here for us. So this first one that we have, this was actually called a point slope formula, and that is if you know the slope of a line and you know a point on the line, you can use this formula to help you find the equation of a line. And this one right here is the slope formula, so that's the rise over run if you're given 2 points on a line. And then these few other things we have is parallel means the two lines have the same slope. So parallel lines means they never cross each other. Okay, means they have the exact same slope. Perpendicular lines means they have the negative reciprocal slope. So that's when two lines are cross each other at a 90-degree angle. So that's just a few that's just a quick overview of some of the things that we're going to be talking about. So let's just go ahead and use that information to just jump right in and do a couple of examples. Okay. So first of all, let's say I want to find the equation of a line with, let's say, slope negative 1/4. And let's say it passes through the point 2, negative 8. Okay, so if this is the information that I'm given, how would I find the equation of a line? And we would go ahead and think about what we're given. We're given the slope and we're given a point. And that point I can go ahead and label x1, y1. So because I'm given a point and a slope, I can go ahead and use the point slope formula. So it's the y minus y1 equals m times x minus x1, and then you just go ahead and plug in everything you know. So the first thing I know is my y1, so this is y minus negative 8 equals negative 1/4 times x minus 2, and then we simplify. This will turn into a y plus 8. This will be a negative 1/4 plus 1/2 when I distributed that across. That's how I simplified that. And then you can continue on to simplify this along the way. This could become then negative 1/4 x. There we go. Y equals negative 1/4 x. And then I needed to subtract 8 from both sides. That'll give me minus 7.5. Feel free to leave that as a fraction or a decimal if you would like. And that gives you the equation of that line. I have the slope and I now have a y-intercept, which I didn't have before. So I could definitely graph that. Another thing, though, that we're going to need to be able to do is talk about the parallel and perpendicular. So how could I find a parallel? How could I deal with the parallel and perpendicular lines? Okay, so this would be something that's find an equation of a line that's parallel to, let's say, 4y minus x equals 20, and passes through the point 2, negative 3. Okay, so if this is what we're given, we have a line that's already given. I want a new line that's parallel. And what we talked about before, just as a review, was parallel means they have to have the same slope. So I need to take that line that's given to me, and I need to find the slope of that line. And the way this line is written, it's not in the correct form. It's not in y equals mx plus b. So I can't find the slope yet. Have to get y by itself first. So I'm going to go ahead and add x to both sides, and then I go ahead and divide both sides by 4. Now that it's in y equals mx plus b, I know my slope is 1/4. Okay? Now that I know my slope is 1/4, then I can use the y minus y1 equals m times x minus x1. So this will be y minus negative 3. Again, I'm just looking at this point that was given to me. Equals, and now it's parallel means I have to have the same slope. So there's my 1/4 x minus 2. And I'll go ahead and put a little dot, dot, dot and let you guys finish that one. But that's the idea behind finding the equation of a line that's parallel. Okay, so another example would be finding the equation of a line that's perpendicular to the line 2y minus 3x equals 6 and passes through the point 1 comma 2. Sorry, that's gonna, I could spell that correctly, there we go. So let's go ahead and think about that. Again, the line that's given to me is not in the y equals mx plus b form, so I don't have the slope of this yet. So I'm going to do this one more time. I'm going to go ahead and get y by itself, divide everything by 2, and I'm going to get y equals 3/2 x plus 3. So this is the line that's given to me. The slope of that line is 3/2. What we want is we want perpendicular. So that means my new slope, the perpendicular, will be the negative reciprocal, which means you just change the sign and flip the fraction. That'll be my new slope, will be negative 2/3. Then that's the slope you can go ahead to use for the y minus y1 equals m times x minus x1. So in this case, it'll be y minus 2 equals negative 2/3 x minus 1. And again, that 2 and 1 just came from the point that it was given me that I'm passing through. And then again, you can go ahead and distribute, combine like terms, and I can let you guys finish that. And that's how we're dealing with the parallel and perpendicular, the equations of these lines, using the slope formulas, using the point slope form, and making sure you get things at the end of the day in a form that looks like y equals mx plus b. And that's your end goal at the end of this. All right? Ta-da!